Hey guys, so you should have just watched your lesson on periodic trends. You should have taken your notes and they should be in your interactive notebook on page 41. The software that I use to record your lessons only lets me record for 15 minutes. So what I'm going to do is break up your notes and then your guided practice. So this video, the PowerPoint is linked, so you can pull it up and follow along, or you can just follow along as you watch it. I'm trying to set your lessons up as close to our normal class as possible. So typically on a normal class day, I teach you guys a new concept, we go over some guided practice, and then you will complete an independent practice. It's going to be the same thing as at home, it's just all going to be done virtually. So after you're done watching these guided practice problems, you guys will go into your quizzes. It's still underneath your assignments for today, so March 30th. You'll go under there and you will complete your independent periodic trends checkup. So let's take a look at some guided practice problems here. We're going to start with the atomic radius. So remember from the lesson you just watched, our atomic radii in our table increases as we move to the left and also increases as we move down. So that means that the elements in the bottom left-hand corner, so these elements right here are going to have the largest atomic radii, okay? And then that also means that these elements up here are going to have the smallest, right? So let's take a look at what this even looks like. Here is your periodic table of the elements. So we already saw in our lesson that francium has the largest atomic radius, right? So if francium has the largest, we can kind of guess that helium will have the smallest, right? Because we increase as we go to the left and as we go down. So let's take a look at application. How are we even going to use this? So this question says choose the element from the pair with the larger atomic radius. So lithium or beryllium. So we're choosing between the two. We're trying to see which one of these is going to have a larger atomic radius. So if we go back, let's find lithium. Lithium is right here on our table. He's in group 1, period 2. And then beryllium is in group 2, also period 2. So if we're looking at these guys, we know that atomic radius increases as we move to the left. So which one of these elements is further to the left? They're both in the same group, or they're both in the same period, okay? So neither one of them are below the other one. So we're just looking at which one is more to the left. And if we do that, we should come up with lithium. So lithium is going to have the larger atomic radius. Now let's look at another one. Silicon or tin. So silicon is Si and then tin is Sn. So let's go back and look at our table. Silicon is right here. It's in group 4A or 14. And then silicon is also in the same group. Okay, so those that are in the same group, we can kind of expect elements in the same group to have similar properties. But these guys are in the same group, so they're kind of in the same position to the left in regards to the left-hand side of the table. But now, what about which one is further on top? So silicon's on top of tin. So remember, our atomic radius increases as we go down. So we can expect tin to have a larger atomic radius because it's below silicon. Okay, let's see if we're right. We are. So to do these problems, really you just have to follow your arrows and see which ones are more to the left, which elements are more to the left, and which ones are further down, okay? So if they're in the same row or the same period, you're going to look to see which one is more to the left, and if they're in the same group, you're going to see which one is further down. Ionization energy. So if we look back to ionization energy, it increases as we move up the table, and it also increases as we move from the left to the right. So our elements up here are going to have the highest ionization energy. So helium should have the most ionization energy, while our elements down here in the bottom left-hand side will have the lowest. So let's look at our periodic table. So again, here's where our higher ionization energies will be, and here's where our lower ones will be. So this question says, choose the element from the pair with the greater ionization energy, silver or iodine. So let's go back. Let's find silver and let's find iodine. So here's iodine right here. Okay. Now let's find silver, which is Ag. You guys, can you point it out for me? I know you can't. I know you guys normally help me in class, but here's silver. All right, silver is a transition metal, and then we have iodine over here. Okay, so remember our ionization energy now is increasing as we move from left to right and from the bottom to the top. So again, silver and iodine, they're in the same period, but which one is further to the right now? It's going to be iodine. So iodine has the highest ionization energy. Okay, now let's do one more for this one. Oxygen or selenium? Let's go find oxygen and selenium. Okay, so here is oxygen, right? He is in group 8A, or sorry, not 8, group 6A or group 16. Okay, so here's oxygen and here's selenium. So now these guys are in the same group, right? So we're going to look. So remember, our ionization energy increases as we move up the table. So the one on top here is going to have the highest ionization energy. So is it oxygen or is it selenium? It should be oxygen, okay, because he is higher up in the table. Okay, so again, you're just following your arrows from your notes and you're choosing the element that is furthest to the right and the furthest at the top. All right, electronegativity. So as, again, same with ionization energy, our electronegativity increases as we move from left to right and from the bottom to the top. So again, remember, electronegativity is a little bit different because our noble gases are stable. So if our noble gases are stable, they're not going to exhibit that electronegativity. So we're not going to worry about the noble gases here. So we're going to look to our next group, which is 7, which is our halogens. Okay, so we're going to look at fluorine. So remember, fluorine is our most electronegative because he is the furthest to the right and he is the furthest up the table. Okay, so let's do a couple problems. It says, choose the element from the pair with the greater electronegativity. So we have sodium or rubidium. So sodium is over here. Okay, he's in group 1, period 3. And then rubidium is also in group 1, period 5. Okay, so sodium's here, rubidium is here, and then we have to go back and let's look, right? So our electronegativity increases as we move up the table. So which one should be more electronegative? They're in the same group, so is it going to be sodium or rubidium? Should be sodium because sodium is further up in the table. Let's do one more and then you guys will do your independent practice. So we've got selenium or bromine. So let's go find selenium and bromine, okay? So selenium here in group 6A or 16, and then bromine in 7A or 17. So bromine's a halogen, and then selenium's over here in our oxygen group. So which one of these is going to be more electronegative? Remember, electronegativity, so these are in 2 different groups, but they're in the same row, same period. So remember, electronegativity increases as we move from left to right. So which one is further right? Is it selenium or is it bromine? Should be bromine. Okay? So those are your guided practice problems for this unit or for this lesson. Go back and watch them as you need. And then once you feel comfortable, go ahead and go ahead and start that the periodic trends checkup. It's a quiz. It won't be a quiz grade. It'll be a classwork grade. It's just putting it in quiz form is the easiest way for me to get this to you guys right now so you can get immediate feedback. You get 2 chances. It will show you which ones you missed the first time, and the highest grade will go in the grade book. So you can take it twice. It's due Tuesday night at midnight. So Tuesday, 3/31, March 31st at midnight. It does have a time limit on it of 90 minutes. Okay, 90 minutes is a full class period. That's plenty of time. Just don't open it thinking that you can go back to it and finish it like whenever. Don't start it until you have at least, I would say, I'd say 30 to 45 minutes to work on it, maybe more if you think you need more time. But don't start it until you have enough time to complete it at once, because there is a time limit. So go ahead and do that at your leisure. Make sure you get it in on time for full credit. And if you have any questions, again, I'll be getting out some information shortly on office hours and Zoom. And then if you have any more questions, send me an email, send me a remind. Good luck.